Hello everyone, my name is Lokesh and in this video we are going to cover the topic factor theorem, which comes under the chapter 2 of class 9th NCERT mathematics. So factor theorem says that if Px is any polynomial of degree n greater than 1, then we have these two conditions 1 and 2, and which are if Px is any polynomial of degree n greater than 1 and a is any real number. Okay, it may be integer, positive or negative, it may depend. Then x minus a is factor of px if pa is equal to 0. Okay, and the second one is just reverse of this first one. If pa is equal to 0, then x minus a is factor of px. 1 and 2 are totally opposite. If one is true, then another one is also true. Okay, for example, using the example, the concept will be more clear. Okay, suppose we have any polynomial px. I am writing this one like x squared plus 2x plus 1. Okay, so factor theorem says that if x minus a, this one, is factor of px only if pa is equal to 0. Okay, so if we have to check for x is equal to minus 1. Okay, so what we will do, x is equal to minus 1, which means the value a in which we are finding is minus 1. Okay, let me write this as a, it will be more simpler. A is equal to minus 1. Then x minus minus of 1, which is equal to x plus 1. Now, if we want to say x minus a is factor of px, then we have to check if pa is equal to 0 or not. So we can simply find p of a, and value of a is minus 1 is equal to minus 1 square plus 2 times of minus 1 plus 1. Minus 1 square is 1, 2 times of minus 1 is minus 2, and then plus 1. So 1 minus 2 is minus 1 plus 1, it is equal to 0. So we got for this PA, which is P minus 1 is equal to 0. P minus 1 is equal to 0, which means x plus 1 is the factor of Px. So first one is clear now. Now we are doing the same thing for that, which says that, okay, it is the first implication and it is the second point. It says that you can read there, pa is equal to 0 if x minus a is factor of px, which means if I say, okay, that x plus 1 is factor of px, and what it is px, it is equal to x square plus 2x plus 1. Okay, so if this thing is given that x plus 1 is factor of px, then there is no need to find the value of px at that is equal to minus 1, which I am saying x plus 1 can be written as x minus minus 1, and on comparing with the definition, we can write a is equal to minus 1. Then without solving, we can simply say p of minus 1 is equal to 0. Okay, when it is given this is the factor, then we can directly say p minus 1 is equal to 0. There is no need to solve these things. It is obvious, and we can say it is done from the factor theorem. So whenever we have to find the factor, we will use the factor theorem. Let me give one more example. check whether at x is equal to 1 is factor of 2x plus 3 or not. Okay, now we will use factor theorem for this example. At x is equal to 1, we have to find factor of 2x plus 3, which means our px. Okay, we can increase the power because we are working on like power greater than 1. 2x square plus 3. It will be more perfect. So we have px is equal to 2x square plus 3. Okay. If we are saying x is equal to 1 is factor, then what is implication? Read in the definition. If x minus a is factor of px, then or this thing pa is equal to 0. So what we have to do, if x plus 1 is the factor of this px, then p1 should be 0. Okay, we have to check this thing. If p1 is equal to 0, then we can say x is equal to 1 is factor, otherwise no. So we can find p1, which is 2 times of 1 square plus 3 is equal to 2 plus 3 is equal to 5, which is not is equal to 0. So at x is equal to 1, we don't have any factor. Okay, that's the point we are going to cover using the factor theorem. Now it's all for this video. After that, we will do some more problems in this. Thanks for attending.